This is Sharma solution, class 12, chapter 6. Determinants exercise is 6.2. So evaluate the following determinants. So almost all of them are similar. A few of them, like the third one and the seventh one, will do separately, but all others the criteria is same. Okay. So let us start with the first one. Those who don't know how to do the determinant, I'll tell you. Let me write it 1, 3, 5, 2, 6, 10. I am doing the first part 2, 6, 10, 31, 11 and 38. So which row, which column we have to use to open this? Normally we use the first row, but if any other row has 0 or multiple zeros, then we can always use that row. So there are 3 rows and there are 3 columns in this. This is a 3 by 3 square matrix. So A11, A12, A13, A21, A22, A23, A31, A32, A33. Why I wrote this? Because when we are going to find out the determinant, what will be the sign we are going to use when we use the numbers in the row or column? It's simply minus 1 to the power I plus j. What is I plus j? The particular element in which row and column it belongs. For example, minus 1 to I plus j, say 2, 1. So if you open it using this row 2, 6, 10, so it will be negative plus negative. Why? Because minus 1 to the power 2 plus 1 is 3. And minus 1 to the power odd is always negative, and minus 1 to the power even is always 1. Okay. So these all which I am pointing, these can be done, they are similar, so they can be done likewise. But the third and seventh we will do. Let us start with the first one. So we'll open it with the first row, which is 1, 3, 5. How to do this? See, 1 we'll write, then we write 3, then we write 5. Now what sign we have to give? Minus 1 to the power I plus j. So this is A11, so it will be even, it will be plus. Minus 1 to the power 1 plus 2, that is going to be minus 1. So in place of 3, just put a minus in front of it. Rest will be positive. So if 1 we are taking, the row and column in which this 1 belongs, will leave it. We only take 6, 10, 11, 38 because they are not coming in the rows and columns of 1. Coming to 3, row and column of 3 we are going to leave. 2, 31, 10, 38 will remain. Right? Then coming to 5. 5 belongs to which row and column? That we are not going to take. The others we are going to take. So 2, 6, 31, 11 will be there. So when we take 2 by 2 matrix, this is A, B, C, D, the matrix determinant is AD minus BC. Same thing here, 6 into 38 minus 10 into 11. Here you get 2 into 38 minus 10 into 31. Then 2 into 11 minus 6 into 31. So this, let me tell you, this is going to be 228 minus 110. So what do you get? 118. 2 into 38 will be 76 and 10 into 31 is of course 310. So when you subtract this, you are going to get negative 234. Again, 2 into 11, 22 minus 6 into 31, and that is going to be 186. 22 minus 186 will be minus 164. Now you have 1 here, you have negative 3 here, and you have a 5 here. Now see, what will be the final answer? The result will be, just add these, or these are just numbers. Wherever minus is there, make it as plus. So we have negative here, so I am putting negative here. So 118 plus 702 minus 820, and this is going to give you 0, because it will be 820, 702 plus 118, right? So others you are able to do, I hope. Now let us take the third one. It has no different way to do. We'll do the same way which we know. AHG, HBF and GFC. Same thing we are going to do. We'll use the first row to open. We'll write A here. Here we write minus H and G. Then what will be inside? the row and column in which A belongs, we don't take it. Other values we take it. So we only take B, F, F, C. In H, again, the intersection of row and column we don't take. H, G, F, C we are going to take. Similarly, in place of for G, we will take H, B, G, F. Now, cross multiplication 2 by 2 determinant. So, BC minus F square minus H, HC minus FG. Then we have plus G into HF minus GB. Right? Okay. Now multiply this. ABC minus AF square minus H square C plus HFG plus again HFG, you can write it as anyways. So HFG minus it will be G square B. Now just rearrange it. ABC and this will be HFG is 2 times, so 2 FGH minus AF square, then minus CH square and minus BG square. This is your final answer. So there is nothing special about this. We just did it the way we do normal determinant. There is no zeros here, no determinant is 0, no properties we used. All others I am skipping except the 7th one. So we'll do the 7th one because I just have to give you an idea about this. What is the idea? Because this is 4 by 4 matrix. So 4 by 4 matrix will be 3 by 3 and then we'll solve it using 2 by 2. Ultimately, every matrix has to come to 2 by 2 matrix. So let me write it like this. So this is, if you are doing it 4 by 4, let me tell you, I have to write each and everything to make you understand. This is 4 by 4 matrix. So we have to find out the determinant. So I'm writing all the numbers here. Calculation you will be able to do, okay. The main thing is the way or the logic or the reasoning behind it. Now you see here, I'm equating this with, because there are 4 rows and 4 columns. So you need to know which element belongs to which place. This is A11, this is A12, A13, A14. This is A21, A22, A23, A24. This is A31, A32, A33, A34. This is A41, A42, A43 and A44. Now you just have to see that whether it will be negative and positive depending upon minus 1 to the power I plus j. I plus j is the subscript of this A. So first row, if I open it with first row, A11, 1 is even. It will be positive. Then A12, which is 3 here. A12 minus 1 to the power 1 plus 2 will be negative. So in front of 3 you are going to put negative. 9, A13, that is minus 1 to the power 4, it is going to be positive. So just write it here. No sign here, means no negative sign. Just write 9 here. Then 27. Since it is minus 1 to the power 1 plus 4 minus 1 to the power 5, it is going to be negative. So you put a negative here. Okay. So this you will do for all of it. Any row, any column you take. Now you have 3 by 3 matrix here. 3 by 3 matrix, all of it. So 3 by 3 matrix you see. 1. So leave that row and column which intersect at 1. What is remaining? 9, 27, 1, 27, 1, 3 and 1, 3, 9. So you have to do this for all other 3. That is, wherever 3, the row and column intersect, you have to leave those all elements. Only other elements you have to put. Same here, 9. So you write 3, 9, 1, 9, 27, 3 and 27, 3, 9. So I am just leaving the rows and column where this element belongs at the intersection. Similarly, 27, the numbers will come as 3, 9, 27, 9, 27, 1 and 27, 1, 3. Okay. Now 3 by 3 I have already told you. You will be able to do it. It will take a lot of time, but you will be able to do it, right? You have to take them as separate entities, find the value and then put it here. For example, the final value, just recheck, it will be 516320. I hope you will be able to do it, right? Without expanding, show that the values of each of the following determinants are 0. Now here we are going to use the properties of determinant. And since it is already given that the determinants are 0, so we'll try to make it 0. So first I am doing it. Let me tell you, if 2 rows are equal or 2 columns are equal, it is 0. Determinant will be 0. If all the elements of any row or column is 0, the determinant is 0. So we'll try to make this such that 2 rows become similar. 8 I can write it as, see, 2 rows, 2 column we have to make equal, then it will be 0. So 8 can be written as 4 into 2. This can be written as 4 into 3. This can be written as 4 into 4. Now 4 you can take common. If you take 4 common, you can always take 4 common. This is a scalar. 2, 3, 4, 2, 3, 4, 7, 5, 3. Now what you see here? You see that 2 columns are exactly similar. Even if you want to do a way ahead, if you want to go forward, you can do one more property here. Change column 1 to column 1 minus column 2. That is, this is 2 minus 2 is 0, 3 minus 3 is 0, 4 minus 4 is 0. You get 2, 3, 4, 5, 7, 5, 3. When whole of the column is 0, the determinant will be 0. Okay. Now let us take the second one. I am taking the other one. So everywhere we have to use this property. So we have 6 minus 3, 2, 2 minus 1, 2, and minus 10, 5, 2. That is minus 3. I'll just change it, okay? So can we do this? Yes, because the second row, second column and the first column, they have multiple of 2. And they are in different signs. So if we make it, there are multiple ways, to put it. So this is 6, 2 minus 10. How can I write this? I can write it this as 2 into 3. I can write this as 2 into 1. I can write this as 2 into negative 5, right? And since we have this sign, because that 3 is not 3, it is negative 3, I'll just change it. So I'm taking 2 outside. What we will get? We'll get 3, we'll get 1. It's not 2, it's 1. I'm just changing it. And we get minus 3 here and minus 1 and 5. So minus 3, minus 1 and 5, 2 to 2 will be there. Okay. So now what you have to do is, you have to just add column 1 and column 2. So change column 1 to column 1 plus column 2. So 3 minus 3 is 0. And this is not 2 as I said, it is 1. Because we have taken 2 already common. So this is 1. 1 minus 1 is 0. 5 minus 5 is 0. So what will be remaining? Whatever is remaining doesn't matter because one column is 0. So the determinant will be 0. Whatever you write. One column, one row 0. So all is 0. Determinant is 0. Okay. So there is one more method. What we have done in 2 or 3 steps, you can do it in one way. C1 can be changed to C1 plus twice C2. It's same thing. I have taken 2 common from first column and taken it out and then added. Here we have just multiplied the other column by 2 and added. Oh, now this one we are doing. So how to do this? 1 by A, 1 by B, 1 by C. So there can be multiple ways. The way to do it can be in a multiple manner. So let us see a more formal way. We have to multiply and divide the scalar such that 2 rows or 2 columns becomes similar. So we'll multiply the first row by A, second row by B, third row by C. What do we get? See, we are changing column 1, you can say, will not do it that way. The row 1 has to be multiplied by A, row 2 will be multiplied by B, and row 3 will be multiplied by C. But here we will, if we are multiplying something inside, we have to divide it also, because from where that number will come. You can write A by A, B by B, C by C, so that will be terminated. So you can, if you are multiplying A, B, C inside, you have to take A, B, C in the division outside, right? Okay. So A, B, C, if you are multiplying inside A, you have to divide it by A. That is why I have taken A outside with division and multiplying A inside. So it will be A 1 by A multiplied by A will be 1. A cube and ABC. Similarly, now multiplying B. It will be 1 B cube BAC and now multiplying by C. So this will be 1, this will be C cube and this is going to be CAB or ABC. Now from the third column take ABC common. You can take ABC common from here. So when you take ABC common, what are you going to get? ABC I am taking, ABC was already outside in the division. This will be 1 1 1. The middle one will remain same, but this will become 1 1 1. 1 1 1, right? So now the first row and the first column and third column are similar. That is, the determinant is 0. If you want to show it, you can just subtract also. First column and third column. I hope you got the idea. So let me just remove this and let us come with the let us solve the others which need some attention, because those which are somewhat similar to what we have done, we are not going to repeat it. I hope you'll be able to do it. Let us come to the next one. Right, okay. So this is, now what you see here is, what you can do is, we have a property that if we can make it a separate addition of different matrices, but that will take us to 6 matrices and that will be a long method. But here we have a chance that we see in first row and second row, if we subtract, we get A, all A. If we subtract second row with third row, we get 2A. So what we are doing is R1 changing R1 to R1 minus R2. So if we'll get a negative A, we don't want a negative A, so that is why we are doing R2 minus RA. That is 2A, A plus B minus 2AB will be what? It will be, BB cancels, it will be minus A. So we don't want that. That is why we are not doing R1 equals R1 is changed to be R1 minus R2. We are doing R1 changed to R2 minus R1. So 2A plus B minus A minus B will be minus A minus will be, it will be A. Similarly, 3A plus B minus 2A plus B. So 3A plus B minus, this again will be A. 4A plus B minus 3A minus B will be A. So first row we have done. Now second row, we will change the second row similar way. The second row, row 2 will be changed to row 3 minus row 2, not row 2 minus row 3, because we don't want negative. Row 3 minus row 2. So 4A plus B minus 2A plus B, it will be what? 5A plus B minus 3A plus B, it will be 2A. 6A plus B minus 4A minus B is 2A. Now what will be the last row? It will remain as same. Okay, now you see 2 I am taking common from here. If you take 2 common, the first row and the second row will become same, all with A. And you know already, when you have A means 2 rows similar, determinant will be 0. Where row 1, row 2 are equal, you get 0. Now coming to the third one. Now third one you can do in a way that first matrix can be 1 1 1 A B C A square B square C square, and then you can take another matrix minus 1 1 1 A B C and minus B C minus A C minus A B, or B C A C A B. You can separate it into 2 different matrices. But will it be a proper solution or an easy solution? Let us see. We'll do it in some other way. We have to do it all so that in certain way we can get the 2 rows or 2 columns equal, right? So this is what the question says. The first thing we'll do is, because we see 1 1 1, so we are changing row 1 to row 1 minus row 2. So 1 minus 1 is 0, A minus B is A minus B, A square minus BC minus B square plus AC it will be. A square minus BC minus B square plus AC. So this becomes A square minus B square you can take, and then you have plus AC minus BC. A square minus B square plus AC minus BC, right? Now the second one, we are changing row 2 to row 2 minus row 3, because we'll be getting 2 zeros. So 1 minus 1 is 0, b minus c, and then we have b square minus ac minus c square plus ab. So you get b square minus c square here, and then you have plus ab minus ac. The last row remains the same, 1c and c square minus ab. Now you see this one. So I am taking a square minus b square plus ac minus bc. We are taking c common from here. Now a square minus b square can be written as a minus b, a plus b. You already have c, a minus b. Now you can take a minus b common. What do you get? A plus b plus c. A plus b plus c. Right? When you take a plus b plus c, what do you get? 0, 0, 1, a minus b, b minus c. Here you get a minus b, a plus b plus c. And the next one, b square minus c square. You can write it as b square minus c, directly write it as b minus c, b plus c. And then you have, you can take a common, you get b minus c. Now you can take b minus c common. B minus c if you take, you get a plus b plus c again. Right. Now c square minus ab will remain. From the first row, I am taking a minus b common. From the second row, we are taking b minus c common. So we don't need to open it, because once you take this, what I just said, if you take this common, then you are going to get the two rows similar. So I am taking a minus b, and this is going to be 1, this is going to be 1. And when we take a minus b minus c common, this will again be a plus b plus c, a plus b plus c. So what do you get? 0, 1, a plus b plus c as the first row, and the same as the second row. So when you have first row and second row same, I hope you got the idea that when we have two rows similar, what do you get? The determinant as 0. Because these two rows, row 1 and row 2, are exactly similar. Determinant is going to be 0 here. Now this 7th one and 9th one, I hope you will be able to do it. You just have to see these pattern and take out something so that you get two rows or two common similar. Right? In the 9th one also, you have to do the same thing. I can see the pattern right here. I am going to do the 8th one. 0xy minus x 0z, and then minus y minus z 0. So what we will do is, because the first row has no z, we will multiply it inside z. But for that we have to take a z as a denominator. The second row doesn't have a y, so you have to multiply it by y. So y will be in the denominator. The third row has no x, so it will be multiplied by x. So there has to be an x in the denominator. That is why I am multiplying first row with z, second row with y, and third row with x. X, y, z was already there. I took x, y, z inside. And since we have x, y, z already in the denominator, it doesn't matter because they are going to get cancelled anyways. Okay. What is the use of this? See, row 1 we are going to do row 1 plus row 2 plus row 3. So we'll add all the content of the column to make it as a one part of row. That is, we add 0 with minus xy with minus yx. Row 1 will be row 1 plus row 2 plus row 3. So what do you get here? Minus 2xy. xy is already there in negative. xz plus 0 minus zx. But since xz and minus zx are in different sign, you are going to get 0 here. So you get a 0 here. Zx and zx, they are same. Now yz plus zy, it's going to be 2yz, right? Same, next thing will remain like this. Let me write it like this. Minus xy, 0 zy. Then you have minus yz, yx, minus zx, and 0. Okay. Now row 1 will change to row 1 minus 2 row 2. Why? You will just see. Twice of this we are going to take, but since they are of same size, we have to subtract them. So minus 2xy minus twice of xy minus xy. 2 into xy, but it will be negative sign. So minus minus will become positive. 2xy xy, and this is because it is minus minus, so it becomes positive. You get a 0 here, right? So first row, first value will be 0. Now 0 minus 0 is of course 0. So it doesn't matter, it will be 0. Now 2yz minus 2 twice of yz or zy is going to be 0. So even if you write other things or not, the one of the row has become 0. So the determinant is 0. Okay, whole of this row is 0. So the determinant will be 0. Okay. Now this 10th and 11th we are going to do, but we'll do it in the later session. Till then, thank you so much. Take care of yourself.